Okay, good evening, Form 5. This is Form 5 Tuesday group. Okay, nice to see everyone again here. Okay, so I hope that you have a enjoyable and meaningful weekend now. Past few years, past few days. Okay. Next year, January, you all go back school. You all know already, right? When school reopen, you all need to go back to school. You go back to school, so you sit in the classroom for last minute revision now. Okay, see what the school teacher can do for you all. Last minute preparation. Prepare you all, arrange your table, chair, your exam hall, then get ready for you to sit for your SPM now. So you have a long time for you to prepare. Okay, come. So for tonight, I want to start with revision paper set 1. Okay, set 1, paper 2. Okay, this paper, I share the paper with you all. Okay, come. Go on. Okay, one moment. This paper. Okay, I want to start with this paper. Can you see the screen or not, everyone? Can see or not? Give me some answer. Can see or not? Can see or not? Yvonne? Yvonne? Can. Okay, come. We start this question. Okay. I believe most of you, I think everybody took the paper, okay, except one or two only. You print yourself, okay? So look at this paper now. Diagram show two types of thermometer. This one is infrared thermometer. This one normal. We use one, infrared one. The other one is digital thermometer. Digital thermometer, you need to put inside your ears, put inside your mouth. You see, come out here, the reading, right? Okay, two types of different types of thermometer. This one infrared, this one digital thermometer. Okay, you can see here, this one can only show one. Okay, hold on. Let me take out a pen first, okay? Why so difficult to take out? Allah. Okay, hold on. Okay, come. You look at here, okay? Now here, 36.5. Then you look at here, the reading 37.05. So this thermometer only give 1 decimal place, 1 decimal place reading. Whereas this one give 2 decimal places. Okay. From here we know already this one got more decimal places. This one only 1. As you already know, right? The more decimal places you have, right, the better. The reason is what? Yvonne, why the more decimal places you have, the better? What is the reason, Yvonne?
More sensitive.
More sensitive. The reading is more accurate. Correct not? When you have more decimal, means more accurate, more sensitive. Okay, come, let's answer the question. What is a physical quantity can be measured? This one very simple. So the answer is what? These two things are measuring temperature. Okay, measure temperature. Okay, look at here now. Answer here, temperature. Okay, so the physical quantity measure here is temperature. So very simple Okay, next question. State the accuracy of infrared thermometer. Accuracy. What is the accuracy? What is the meaning of accuracy? Accuracy of infrared here. So what is the accuracy? And Jatam, how to answer? What is the accuracy of this thermometer, the infrared thermometer? What is the meaning of
0.0?
What is the meaning of asking accuracy of the thermometer? What is your answer, Raymond? No. Angel, one more time.
0.0 degrees C.
No. Never mind. Okay, try again. Never mind. Let's call another one. Don't need to worry. Okay, answer wrong is okay. One, don't worry. Okay, Pong Yong Eun. Come out, please. Pong.
Yeah,
What is
sir.
the accuracy of infrared thermometer?
0.1 degrees Celsius.
Yes, correct. The answer is 0.1 because the reading here given 1 decimal. 1 decimal actually stands for 0.1. Okay, 1 decimal means 0.1. Okay, so the accuracy here means refer to the smallest division. So here the smallest division is 0.1 degrees Celsius. So the accuracy, if the question asks the accuracy, answer 0.1. If the question asks sensitivity, also 0.1. Remember same one, no? Accuracy refer to the smallest division. Sensitivity also refer to the smallest division. So same answer here. Okay, Okay, next. Which thermometer more sensitive? More sensitive, you should know the answer already. So the answer is the one with the 2 decimal Q. Okay, Q. Q is more sensitive. Okay, because it has 2 decimal places, right? But now next one, they ask you to give a reason. No? What is the reason you say Q is more sensitive? What is the reason? What is the reason saying that? Okay, come, let's hear from somebody else here. Hoa Khai, Tai Hoa Khai. Why we say Q is more sensitive? What is the reason? Hoa Khai?
It can detect smaller changes.
Yes, very good answer. It can measure up to 2 decimal places, means it can detect smaller change. Okay, it can detect smaller change in temperature. Okay, that's the reason why we say it's more sensitive. 2 decimal mean I can detect smaller change. It can detect smaller change in temperature, so more sensitive. Okay, yeah. So we can move on now. I think. The next question number 2. This one. Diagram shows an insecticide sprayer. Okay, this one spray the insecticide. Okay, how this thing work? Let me explain a little bit first. By pushing the piston, when you push the piston, right? Okay, push the piston here. You push, right? It will force the air come out. The air come out very fast, high speed. The air will come out very fast, high speed. When the air move in high speed based on Bernoulli's principle, right? High speed, it become low pressure, okay? High speed, low pressure. So here the air move in high speed, so here become low pressure. When here is low pressure, the higher atmospheric pressure from here will come in. This atmospheric pressure become higher, right? It will push this liquid to go up. Okay, it will push to go up. Because here become low pressure. So here higher atmospheric pressure push the liquid go up. Once the liquid go up here, so it gets spread out. So it will spray evenly outside. Okay, it will spray out. Okay, name the physics principle. What physics principle involved here? What physics principle involved? Okay, Xiao Hui, Ang Xiao Hui. What physics principle involved here? Ang Xiao Hui. Name the physics principle involved.
Bernoulli's principle.
Yes, correct. Bernoulli's principle. Okay. Here. The answer is Bernoulli's principle. Always remember, Bernoulli's principle say high speed, low pressure. When the water flow very fast, it become low pressure. High speed, low pressure. Okay, high speed, low pressure, Bernoulli's principle. Okay, next. Next one is they ask you to pick one. Which region experiences low pressure? So you know lah, you see the diagram, you know already咯. Between X, Y, Z. So the Y is low pressure, isn't it? Okay, so you take Y. Y is low pressure. Then once again, you see the SPM start question. They ask you, give one reason. Why the Y is low pressure? What is the reason you want to give? Give one reason for your answer you put here. Why actually is wrong. No, supposed to cross here. Sorry, I go and type the X, type the Y. Actually, supposed to put cross X. Okay. Okay. Now, what is the reason you want to give? Liao Jinning, what answer? Liao Jinning 出来可以吗？ Liao Jinning. What is the reason for choosing Y? Why the Y you say low pressure 咧？ Liao? Liao Liao Jinning 有在吗？ Are you? What is the answer 咧？ Why the answer? What is the reason of choosing Y as region of low pressure? Why? Liao Cannot Okay, now let me try other student Tan Yun Si. Tan Yun Si, are you there? Tan Yun Si?
Yes,
Tan, okay. What is the reason of choosing Y as the lowest pressure region? Why?
has high speed.
Yes, correct. Because the A move with high speed. At region Y, right? The A move in high speed. Okay, that's all. A move with high speed. When the A move with high speed, it become automatically low pressure. A move with high speed over there now. Okay. The next one. Explain how the instrument produce a fine spray. This one got a lot of marks, you need to write, you need to explain. Okay, just now I explained to you already how this thing produce a fine spray. Okay, I explain one more time, you listen. Then I let you write yourself, later on. 自己写知道吗? Okay, it's like this lah. When the piston push inward, the A and X is forced to flow out with high speed. So the A flow out with high speed. So you say, region of low pressure is created at Y. You say like that, because A move with high speed. Based on Bernoulli principle, regions of Y become regions of low pressure. Okay. Then you say higher atmospheric pressure will push the liquid move into the tube, move into the narrow tube. Okay. So higher atmospheric pressure push the liquid enter into the narrow tube and then get spread out. It's spread out here lah. Okay. Okay. Now you write yourself. Okay. Come try. It's a time for you to train yourself to write. Now mind. You write yourself first. Later on, I will show you the answer. You can check your answer later on. Okay. Come try. Practice to write. Practice, wait, practice right now. Then I call your name, so I want you to hear. I want to hear from you your answer. No. Okay, come. Let's hear from someone here when I call you. Try that, don't worry lah. Just try only. Jonghan, Go Jonghan. Go Jonghan, are you there? Go Jonghan,
Yes.
try. Can you try to tell us your answer? Just try only. Don't worry about right or wrong. Okay, go. Just
Okay,
try.
okay.
Okay, try.
Push the piston inward.
When the piston is pushed inward,
The air in X is moved with high speed.
yes, correct. The A in the X move in high speed,
Which is lower pressure.
which is lower pressure. You must mention now which part become lower pressure. Got mentioned
Y.
or not? Got
Y.
regions of Y become low pressure lah. Okay, next.
And
Next,
at the end, atmospheric pressure push the liquid into the narrow tube.
Yes, correct.
And then spray.
Okay, cut lah. Like that, your answer is correct already lah. Okay, please check your answer now. Okay. So the answer is like that. Okay, you not necessary to follow exactly lah. You see, you don't have to only you add a little bit lah. When a piston is pushed, A move out the narrow holes to region Y. Okay. Region Y has low pressure. Okay, here actually I left off something now. A move out in high speed. Move out the narrow holes to region Y with high speed. Okay, actually here should add high speed. Sorry. Here you add When the piston is pushed, A move out the narrow holes to region Y with high speed. Okay, here we add high speed. Then region Y has low pressure. Region Y become low pressure. Then higher atmospheric pressure pushes the liquid up to the narrow tube, and the fine spray is then produced. That's all. Okay, 2 marks. Yeah. Got the answer already, everyone? Okay, here, like you copy, here, please copy here. High speed, here must add high speed. Okay, here add high. Speed very hard to write, like you mouse. High speed, okay, Okay, high lock. Okay, give up. Okay, no need. Okay, finish everyone. Xiaohui, finish or not? Ang Xiaohui?
Yes, sir.
Yeah. Finish,
Yes.
Okay, come, let's move on now. Okay. Next question, number 3. This question 3 is something to do with wave. Okay, you see the diagram, you know already. This is a water wave. Diagram show the water wave experiences diffraction. This is diffraction. You see the water wave. Water move here, got something here to block the water, right? So when the water pass through the gap, so it become curved shape. This is spread out. So the water wave gets spread out. So this is diffraction. After passing through the narrow gap. Okay, now the question. What is meant by diffraction? Diffraction is what? How to define diffraction? You must remember, what is diffraction, what is reflection, what is interference, right? What is refraction? All these things must know, So now come back to this question now. How are you going to explain what is diffraction? What is diffraction now? Let's hear from Apple. Apple Lau, are you there? Apple?
Yes, teacher.
Apple, come try. How to explain diffraction? Diffraction is what?
Spreading of wave through a narrow gap.
Yes, almost correct lah. Your answer. The spreading of the wave after it pass through a gap. Okay, should be like that, lor. It's a spreading of the wave after it passed through a small gap or it passed through a small aperture. No, pass through a small obstacle also can. So remember, no, this is a definition for diffraction. It's a spreading. The keyword is spreading, is spread out, okay? Spreading of the wave after it passed through a small gap, okay? So that is diffraction. Liao Jingning, got it or not? Liao Jingning, minh bài mà?
Yes.
Okay, The next question. What happened to the wavelength after passing through the narrow gap? Wavelength got changed or not? You see it carefully. Lambda here, after diffraction got changed or not? Liao Jingning, what happened to the wavelength?
Increase.
Yaga, you sure ma? Diffraction or lambda will change or not?
Constant.
Sometimes you are cheated by the diagram, During diffraction, lambda no change one, Lambda remains the same, okay? So remain the same. You must remember, no? Okay, come let's revise a little bit now. During diffraction, lambda never change, frequency never change, speed never change. Okay? So then what will change then? Lambda never change, frequency never change, the speed never change. So what will change? Direction will change, isn't it? You see the direction change already, like they go straight and now like that already change direction. Direction changes. One more change is what? 单接音单接音可以出来一下嘛？单接音，no sound very quiet，no sound 单接音。单音字during diffraction what will change direction changes, what else?
Pattern.
Pattern can have the shape it become curved shape, right? The pattern, correct. And one more is the amplitude. You remember or not? When pass through the gap, the amplitude become lower. Amplitude decreases because loss of energy. So amplitude decreases. Remember that. Make note that. Jot down lah. Okay, this one done already. Next. On diagram 3.2, draw the wave pattern after passing through the barrier as the size of the gap is increased. So you get this answer now, like that. Now the gap become very big. So the diffraction now become not obvious. Not obvious means it only curve a little bit, only bend a little bit, like that, bend a little bit only, not curve shape. Because the gap too big, lambda smaller than the gap, so diffraction is not obvious. So not obvious, so the shape is like that. Okay, diffraction is not obvious. Okay. Then if the diffraction is obvious, it's supposed to be curved shape like that one. No. Okay. Like that one. This one is when the diffraction is more obvious. Okay, you get like that. When the gap is small, you get this answer. More obvious diffraction. When a gap is big, so less obvious, so it's like that. Okay, so please make notes. Okay, finish. Okay, come. Next part of the question. Calculate the wavelength of the incoming water if the velocity is 50 and the wave frequency is 23. Okay, you are asked to find the wavelength. Is given the velocity 50 and the frequency 23. So very simple lah. What formula to use here? Tan Wei Yi, what formula to use? Tan Wei Yi.
V equals to F lambda.
Yes, correct. V equal to F lambda. So use this formula lah. V equal to F lambda. So you find lambda. So it's V divided by F. V 50, F 23. So you get 2.17 meter. That's the answer lah. So the lambda is 2.17 meter. Okay. Very simple calculation here. Everybody must get these 2 marks, you know. Okay. Focus lah. Everybody focus lah. Self-discipline now is very important, you know. You cannot go to school now become you have very much rely on yourself already, your self-discipline. Okay, you must have your self-discipline, stay home, pay attention in tuition classes, school teachers, online classes, pay attention, understand? And then study well at home. Self-discipline is very important now. Okay, this one done. The next question 4 now. Diagram show a simple transformer. This is a transformer, okay? You can see here got primary coil, secondary coil. You have the 2 lines, so this transformer lah. So this is AC 240 volt. Here, there's a diode here, diode, and then the output here is 5 volt, 8 watt. So the voltage reduced already lah. So what types of transformers? So step down. Okay, no problem. This one, step down. 240 step down to 5. So step down lah. Okay. Step down transformer. And come now, let me ask you all. When we talk about step down transformer, right? They must have certain criteria, one, you know, or we say characteristics. Can you tell me now two characteristics of step down transformer? So what characteristics the step down transformer have? Okay, come, let's hear from Avril. Avril Ong. Avril, please come out, Avril.
The number of turns is lesser.
Yes, correct. One is the number of turns in secondary coil lesser than primary coil. Must state accurately like that. The number of turns in secondary coil less than the primary coil. There's one. One more, Avril. One more characteristic of step down. Any more?
I cannot remember another one.
Another one, very simple one. You say the output voltage here, output voltage lower than the input voltage. That's all. That's called step down. The output is 5, the input 240. So much different, isn't it? That is another characteristics. The output voltage lower than the input voltage. Okay, just make notes for yourself to understand. Okay, so we cannot just learn the answer only, you know. You have to know more things. So when I say something important, you jot it down, okay? Yeah. The next one. Why the bulb is lighted up? Very weird question, you know. Why the bulb in the secondary coil is lighted up? They ask you why the bulb is lighted up. How are you going to answer? Then some more, you see how many marks given in the question. This question got carry how many marks? 2 marks, you know. 2 marks means you need to write at least 2 points. Why the bulk secondary coil lighted up? 2 marks question. Okay, class. So how to explain? You all can think a lot. Cannot every time I give you an answer, you copy like that. So you rely too much on the teachers. Suddenly in the exam, you cannot write one, Can you all try or not? Try to explain, or you write it down on a piece of paper first. Why the bulk in the secondary coil is lighted up? 2 marks. 2 marks cannot be one sentence only. Okay, cannot. Okay, try now. Try now, everyone. Try now. Try to write the answer. Practice lah. Now is a time for you to practice. The more you practice, you become better. Okay, practice. Okay, come. Can I call Kelvin? Kelvin Chi? Kelvin, can you come out, please? Kelvin?
Yes.
Kelvin, Kelvin, can you try to explain? Just try only. Don't worry, you get wrong or right. Don't worry, just try. Kelvin, why the bulb is lighted up?
The output voltage meets the demand of the bulb.
Yes, your answer is correct lah, but you get 1 mark only out of 2. You only say output voltage, but you never explain how the output voltage come. So I think like this lah, to get 2 marks, you must explain how the output voltage is there. And finally, you say because of the output voltage, okay, the output voltage will light up the bulb. That's all, 2 marks. Okay, now come, you see the answer. The answer is very long. Jot down the answer, please. When current flow into the primary coil, this is the full explanation, When current flows into the primary coil, the coil and the core are magnetized. Both of them become magnet. Then varying magnetic flux link over to the secondary coil. The varying magnetic flux then will cut over to the secondary coil. Change in magnetic flux produces induced current in the secondary coil, which light up the bulb. Okay? Change in magnetic flux produces induced current. Here you can say induced current, you can say induced EMF or induced voltage is okay one. In the secondary coil, which light up the bulb. Okay, please remember this answer. I tell you, this is a working concept, working principle of transformer. You have a very big probability. This question can come out one, You must know how to explain how a transformer works. This answer. Okay. Okay, finish or not? Yeah. Okay, come. Let's move on to the next one. When the transformer is on, the bulb lighted up with normal brightness. So what is the output? So it's 5 volt lah. Okay, once again, when you line up with normal brightness, right, meaning that the bulb receive the required voltage lah. So required voltage is 5 volt. That's why the answer 5 volt. Understand? Understand now? So it's very important. Please highlight the words normal brightness. When you line up with normal brightness, means it will receive the voltage it want. It want 5 volt, so you get 5 volt. Okay, so that's why it will light up with normal brightness. All right. Okay, next. If the number of turns of primary coils is 960, primary coil 960, calculate the number of turns in the secondary coil. Okay. So you already know just now, here VP, okay, voltage of primary coil 240, VS voltage of secondary coil 5, okay, 5 volt. Okay, now the question is, they are asked to find number of turns in primary coil. Here, 960 turns. They ask you to find how many turns here. So the formula you use is this one. Okay. The actual formula you have learned is NS, actually it's like this law, NS secondary, because divide by NP, okay? Secondary to primary, and then equal to VS, voltage of secondary, divided by VP, okay, like that lah. There are so many formula. One of them is like that, NS, NP, VS, VP. So you want to find NS, so NP bring over, so you get this formula. Okay, NP 960, VS 5, VP 240, so you get 20. Okay, so very easy, get 20 marks, 20 volt, sorry, not 20 volt, 20 tons. 20 tons, and then the marks is 2 marks, okay? Okay, next question. If the input voltage replaced with the inputs of direct current, use direct current, so what happened? As you already know, transformer only can work with AC, only can work with AC one transformer. Here must be AC, come out here also must be AC one. Because transformer must only use AC to work. Because it might produce a magnetic flux, can cut over here, go back, cut over here, go back. So that one must be AC current. So now, accidentally, you replace with DC. So what happened? Change to direct current definitely cannot be used, right? So the answer is about not lighted up, okay? Not lighted up. Not lighted up because transformer cannot function, but when you supply direct current, transformer cannot work. So the bulb not lighted up, okay? Next. Next question, number 5. Study the question carefully now. 5.1 show a light travel from A into the glass, from A into the glass, A into glass, okay? 5.2 show the light travel from A into the diamond. This is diamond, you see, into the glass, it bend a little bit. This angle 35, bend a little bit. When it go into diamond, it bend a lot. bend a lot until this angle become only 21. Bend, refract a lot lah. You know the reason, right? Because diamond denser ma. Okay, now the question. Speed of light, I see speed of light got given. Speed of light in the block, glass block is this one. Speed of light in the diamond, slower lor. It moves slower. Because diamond density higher. Density higher, the light moves slower. Cannot move fast enough because the molecule too packed. Too packed are hard for the light to go through. Okay? Besides, it moves slow. Okay, now the question. Name the light phenomenon, so refraction. The bending of light, so is refraction, refraction, okay? Okay, next. Compare. I'm sure they'll ask you to compare one. Compare the speed of light. So 5.1 speed higher than 5.2. Class, don't write like this. You must write in a sentence. You write speed of light in diagram 5.1 higher than diagram 5.2. Okay, write in one sentence. The speed go through the glass is faster compared to go through the diamond. So 5.1, the speed higher than 5.2. Okay. Okay, next. The angle R also very obvious already. Angle R, this one bigger than this This one 35, this one 21. So same lah. 5.1 bigger than 5.2. Right in one sentence. Angle R in diagram 5.1 bigger than 5.2. Okay. And then next one, refractive index. This one you need to calculate lah. The refractive index. End of the glass block and the diamond, not calculate that. They ask you to compare the reflective index. How do you think? How do you think the reflective index? Who is supposed to be bigger? Brian. Brian, can you answer, Brian?
Glass. Glass.
Who is higher?
The diamond higher.
Diamond higher law. Okay, you know why not? Diamond density bigger. When density bigger, so the refractive index become bigger. Okay. Yeah. You see the density one. When the density higher, the refractive index become higher. Actually, it's like this one. No, refractive index is a measure of ability to bend the light. Diamond can bend the light more. When diamond bend the light more means diamond has bigger refractive index. The ability to reflect light is more so bigger lah. Remember that please make notes Make note there you write lah. By diamonds has higher density. Okay, higher density, so the refractive index is bigger. Okay, so make notes. The next one, compare. No, compare already. State the relation between the speed and the angle R. So, what is the relation between the speed and the angle R? Someone asked question. Come, let me see. Desmond, Halama, don't type like that lah. Desmond. Desmond, not good lah. Desmond. Okay, now next. State the relation between the speed of the light and the angle. Desmond, can you answer? What is the relation between the speed and the angle R?
Directly proportional.
Yes. The higher the speed of the light, the larger the angle refraction R. Yes. Don't give answer directly proportional because there's no graph there, no graph, so you cannot say directly proportional. You say the higher the speed of the light, the larger the angle refraction. Refraction, the spelling wrong, okay? Refraction. Refraction, please check the spelling, okay? The higher the speed of light, the larger the angle refraction. You can confirm with the diagram. You see, this one faster, higher speed. This one slower. When higher speed, the angle big. When slower, the angle small. Correct not? So the higher the speed, the bigger the angle R. Okay. Yeah. Okay. Next, relation between the refractive index and the speed. Refractive index and the speed. So what relationship here? Selena, are you there?
Yes.
Selena, can you tell me what is the relation between refractive index and the speed?
The higher the refractive index, the smaller the speed of light.
Yes, correct. Very good. Okay, Selena. The higher the refractive index, the smaller the speed of light. Okay, that's the answer. The higher the refractive index, for example, in the diamond, refractive index bigger, right? But if the light moves slower, the smaller the speed of the light. Okay. Yeah. All right. Next. Diagram shows a situation where Ahmad can see the image of the fish in the water. Where's the diagram? It's here. Okay. So it's like that, lor. So what he see, this Ahmad see the fish is here, So this is an image of the fish actually. The actual fish is here. Okay, the actual fish is here, So meaning that when Ahmad wanted to shoot the fish, he should point it further down a little bit, Cannot follow here. This one is an image of not the actual fish, because the light bend, the arrow is wrong now. Actually, the arrow should be like that one. The light move into the eyes of the observer. Okay, the light go like that, right? But when he see, it become a straight line, so the image appear here lah. Now the light go into the eyes. When the eye see in a straight line, so the image here. So I'm sure this question asking how this man want to shoot the fish. When you want to shoot, you shouldn't directed to here. It's further down. Then only kena the fish. Understand? Okay. This diagram, I think you can copy first. But change the diagram. The arrow come out here, bend into the eyes. So arrow follow what I do here. When you see in a straight line, so the fish is here. Okay. Okay. Come on, please take the diagram. Yeah, finish, Kelvin, finish or not?
Yes.
Okay, come, we move on. Okay, next question. Draw two lines. This one done already. Okay, next one. Next question, okay. Diagram 6.1, 6.2 show cross sections of this cross tube, okay. The cathode ray produced when the electron emit from the heated cathode, you remember or not? When here cathode hot, the electron come out. Okay. The shadow and the green light regions on the screen deflected when the power supply is turned on. You on this power supply, okay? This high voltage. Okay, come, let me explain. There are two high voltage here. One is here. This high voltage. This high voltage just to accelerate the electron, make the electron fly very fast. But when this high voltage, another one, no. This high voltage will deflect because it can make this sun here become positive. Okay, here is positive because connected to positive, and then the other one connected to negative lah. So because here is positive, this one is electron. Electron will be attracted to the negative side. Okay, that's why it fly, it go down lah, because got electric field here, high voltage. Okay, now the question. You change to 5,000, it deflected more lor. This one deflected a little bit. When the voltage is higher, it deflected more. Okay, that one common sense now. Okay, now the question. Name the process emitting electrons. So thermionic emission. The answer thermionic emission. State one reason why EHT is used. What the reason? Why we need to use extra high tension power supply? Why then? Okay, come, let's hear from you all. Chan Ching Yi, are you there, Chan Ching Yi?
Yes.
Why we use extra high tension power supply? Why?
To accelerate the electron.
Yes, to accelerate the electron. Produce high potential difference to accelerate the electron. Okay. Because high voltage, right, can produce a high potential difference to accelerate the electron, to make the electron fly. Okay. Okay, next one. Compare. You see that the question star is like that one. Sure, they will ask you to compare. Given you two diagrams, 6.1, 6.2. You have seen the two diagram, right? 6.1 here, 6.2 is here. And then they ask you to compare now. The magnitude of potential difference. So how to answer? I don't want to give answer. You give the answer. Ko Ching Ni. Can you give the answer for this? Ko Ching Ni.
Yeah.
Can you give answer? Compare the magnitude of potential difference in 6.1, 6.2.
The magnitude of potential difference of HT in diagram. The magnitude of potential difference of EHT in diagram 6.2 is higher than diagram 6.1.
Yes, correct. Okay. 6.2 higher than 6.1. Yeah. In 6.2 higher than 6.1. This one done already. Next one, compare the angle deflection. Okay, come. Angle deflection. Someone please answer me. Angel Tam. Angel, right? Compare the angle deflection of shadow in and the green light. Angel, answer please. Angel, where are you? Ang Xiaohui, can you answer? Ang Xiaohui? Ang Xiaohui, not there also. Selena. Selena, you 在吗?
Yes, sir.
Selena, can you answer? Angle of deflection, can you compare?
The angle of deflection of a shadow and a green light region in diagram 6.2 is bigger than 6.1.
Yes, correct. 6.2 bigger than 6.1. Okay, same answer. In a 6.2, deflect more. 6.1, deflect less. Okay, huh? The next one. Direction of deflections and the green light. Okay, it's the same lah. The direction of deflection of a shadow and a green light shadow, both also same direction. Okay. Both also deflected to the positive side, positive plates. So both same direction now, huh? Okay, next. Based on the diagram 6b, state the relation between the magnitudes of potential difference with the angle deflection. This one very simple. Can you answer it? Relation between the magnitude of potential difference and the angle of deflection. Okay, come, let's hear from Fu Hui Wen. Are you there now? Fu Hui Wen, you 在吗?
Yes.
Fu Hui Wen, can you answer? What is the relationship between the magnitude of potential difference and the angle deflection?
The larger the magnitude of potential difference of EHT, the larger the angle of deflections of the shadow.
Yes,
and the
very
green
good.
light region.
Yeah, correct. Very good answer. Thank you, Fu. Okay. The higher the potential difference, the bigger the angle deflection. Okay, very simple lah, huh? Okay. The higher the potential difference, the bigger the angle of deflection. Okay, huh? Okay, next one. Diagram 6.3 show two magnets with the opposite pole are placed. Okay, you have to put a magnet there already. Put magnet. Okay. Okay, when you put magnet, this thing will move up. But the answer you can jot down first. But can you explain how to get the answer go up? This is the answer. The direction of this thing move, it will move up. But can you find the solution to explain why? You explain to me why then why the arrow go up. Draw an arrow to show the direction of deflection. Okay, so the arrow is go up now. How to determine this one? How you determine this one? Okay, come. Cú Kian Ming you 在吗? Cú Kian Ming Cú Kian Ming. Also not there. Ong Pian, are you there? Ong Pian Ong Pian cannot talk. Okay, now my Ong Pian, can you type? Okay. Using what method to get this answer? The arrow go up. Yes, the answer Fleming's left-hand rule. Yes, correct. Using Fleming's left-hand rule. Okay. You know how to use Fleming's left-hand rule. You try yourself until you get this answer. Okay. Your first finger first finger is this one. Okay. This one show magnetic field. Magnetic field must follow north to south. Okay. And your second finger, this one, follow directions of current. The current is go here, go inside, go in, go to the left side. Why? Because electron moves to the right. Electron fly to the right, current move to balik, current flow to the left. So remember electron moving to the right, the current to balik, that's why the current go here. So your first finger follow this direction, second finger follow here. So your thumb point up. thumb point up, that's why the arrow go up. Okay, this one you practice yourself. The next, Fleming's left hand rule. Okay, the answer. Fleming's left hand rule. Fleming's left hand rule. The next question. Number 7. Okay, I give it 2 minutes. You go and try first. Okay, try to answer the question. Okay, try to work out first. Diagram show the arrangement apparatus used to investigate relationship between the pressure and the temperature. Okay, relation between the pressure and the temperature. So the fire is here no fire so just to see the temperature and the pressure. So you have ice here, stove. This is stove, right? Stove will heat up the water So the temperature we're getting higher and higher. Okay, we're getting higher. So common sense only when you see the temperature become higher, right? Definitely the pressure go up one. Okay. Yeah. So now answer the question. Gas law. What is a gas law? What gas law here? Assuming. What gas law here?
Pressure's law.
Yes, pressure's law, because pressure and temperature, so it's pressure law. Okay, pressure law. The next. Based on the experiment, sketch a graph pressure against the temperature. Pressure against temperature, I'm sure you know when the temperature getting higher, the pressure become higher. Okay, hot when it getting hot, sure the pressure become higher one. So it should be a graph like that, directly proportional graph Here no, because temperature is in Kelvin. When it is in Kelvin, it start from 0. Okay. When the temperature is in Kelvin, it start from 0. Okay, please make notes, jot down here. When the temperature start with degrees Celsius, here temperature degrees Celsius. So how the graph look like? When temperature is degree Celsius, right, it doesn't start from 0, it starts somewhere here. So it becomes like that. So when you extend the line, when you extend the line, you get a temperature here. So this temperature is negative 273. So remember that. Please jot down this graph. When it's in Celsius, you start from here. When you extend, you get negative 273. When it's in Kelvin, you start from 0. Jot down, please. And this negative 273, you given name. What is the name of this temperature? Negative 273. What is the name of the temperature? Jiafeng. Jiafeng. Lim Jiafeng. What is the name of this temperature? Negative 273. Sinh Phi. Wun Sinh Phi. Wun Wunอยู่ใจมาHoa Khai. Tai Hoa Khai. Tai Hoa Khai, are you there?
Critical zero temperature.
Say it again. What is that? Hoa Khai?
Critical zero temperature.
No. Can someone please help to get the correct answer?
Absolute zero.
Absolute zero. This is absolute zero temperature. Please jot down. Absolute zero temperature. Absolute zero means that this is a real zero. Absolute zero. Because this temperature equal to 0 Kelvin. Equal to 0 Kelvin, so it's called absolute zero temperature. Okay, Okay, so this one done. Next. State the temperature given already lah. They already asked, so before they ask already tell you already. State the temperature degree Celsius. Okay, it's negative 273 degrees Celsius. Okay, Okay, now the pressure of the gas in a container is this, and the temperature is 2. Calculate the pressure of the gas when the temperature increase to 32. Okay, do now. 2 minutes. Formula to calculate. Pressure law formula. Go and find the pressure law formula. What is the formula for pressure law? Coaching me? What is the formula for pressure law lah?
Teacher, wait.
Okay, I wait. You have pressure and temperature, P and T. So the formula is what? Okay, Tan Wei Yi. Tan Wei Yi, can you help? Tan Wei Yi? Chingni, you got the answer already? Call Chingni?
Teacher, I'm still finding.
Still fighting. Okay. Tan Wei Yi. Tan Wei Yi, what formula? Pressure law formula is what?
P divided by T.
P1 over T1 equal?
P2 over T2.
Yes, correct. P1, pressure 1 over temperature 1. P1 over T1 equal P2 over T2. Okay? Now the formula here. So the answer is here. Okay? Now you can check. P1 over T1 equal P2 over T2. Pressure 1, this one. T1, 275. Where do you get 275? Where do you get this value? P2, you asked to find. Then where to get this value 305? You must know, where to get this value? Where to get those value? Okay, come. I want to hear from Yvonne. Yvonne 出来 Yvonne Yvonne 来哦
Yes, sir.
Yvonne can you explain now how to get 275 here? How to get 305 here?
Plus 273.
Yes. 2 degree plus 273 you get here. This one is 32 plus 273. Okay, thank you, Yvonne. So this temperature make note that must change to Kelvin. Must be in Kelvin, change to Kelvin. Celsius to Kelvin, so you add 273, you get this one. 32 add 273, you get this one. You don't add 273, so your answer definitely wrong. So please make note, this is not 10,105, this is 10 power 5. Okay, please make note. Power 5, okay? Yeah. Okay, got it? Okay, come, next one. Diagram show a pot that can function as pressure cooker. This one is pressure cooker. Okay. So for pressure cooker, you have cover, you have a valve. This valve is to release the pressure. Sorry, safety valve here to release the pressure. This is the main valve. So you have two, Okay. Then you have thin aluminum wall. This thin aluminum wall definitely cannot, because thin cannot stand the pressure. Actually, the aluminum wall must be thick, cannot be thin. Okay, because pressure wall will experience very high pressure one. Okay. So now, what the question asks? Using kinetic theory, explain why the pressure of A in the cooker increase when the temperature is increased. Okay, come, try to answer. 2 minutes. Using kinetic theory. When you see kinetic theory means you must talk about the molecule of gas. Okay, using kinetic theory, explain why the pressure of A in the cooker increase. You must explain using the molecule, the gas molecule to explain. Yeah, 2 minutes time now. Yeah, come. I want to hear from Pong. Okay, Pong Yong Ân Pong, 出来 Pong
Yeah, so
Pong, can you try to explain why the pressure is increased, the temperature increased? Why?
when the temperature increase, the air particles collide one another more frequently.
Like that
Kinetic energy increase.
Okay, come now. Pong, half correct your answer Okay. Never mind. I want to hear from one more student. I feel very worried about you all, One more, I want to hear from you. Kelvin Kelvin G. Kelvin, can you come up?
Yes.
Kelvin, can you try to explain why the pressure increase when the temperature increase there? Kelvin?
My answer almost same as the last one.
Yamai, I want to hear from you. Can you say one more time?
Gas molecules collide against the walls of the...
Yes, your answer is correct. The pressure comes from the A molecule when it collide with the wall of the container, not collide between the molecule. No, it's collide with the wall of the container. So the answer is like this lah. Okay, see the answer lah. The answer, I don't know whether it's correct one or not. See is here. When temperature increases, a molecule gain more kinetic energy. So frequency of collision with the wall of the container, you must write this on. Frequency of collision with the wall of the container increases. That's why higher pressure is produced. Yeah. The pressure comes from when the molecule collide the wall of the container. Okay. Okay, got it, huh? Okay, next one. Suggest a modification to the pot that enable to function safely as a pressure cooker. One only, a modification. You look at here lah. So which part need to be modified? 写成语出来可以吗？写成语啊，写成语有在吗？
有
出来大声一点啦。
啊
Yeah, when you look at this diagram, which part need to be modified?
in aluminum wall.
Yes, we cannot use thin aluminum wall. How you modified it? How you modified it, Sia?
Thick aluminum wall.
Yes, correct, no? You must make it thicker lah, because the pressure so high. So this wall must be thicker lah. Okay, thank you, Sia. So the answer is use a thicker aluminum wall. Okay. The reason is it is stronger and can withstand higher pressure. Okay. Use a thicker aluminum wall because it can withstand, it is stronger and can withstand higher pressure. Yeah. Got answer, everyone. Yvonne. Got answer or not, Yvonne?
Yes.
Got Brian, do you get answer?
Yes.
Okay, good. Tang Ming Yi, do you get answer?
Yes.
Okay,
Yes.
Chai Yong, Tan Chai Yong, get answer or not? Tan Chai Yong. Tan Chai Yong, you get answer or not?
Yes.
Tan Chai Liang, ZL.
Yes.
Tan Chai Yong, your brother there or not?
I'm here.
Huh?
Yes, I'm here.
Together with you are your brother, huh? Okay, that's fine. Okay, Tan. Okay, come next one. Number 8. Okay, now read the question. Diagram show induction lamp. This is a lamp, not normal lamp. About, okay. The lamp uses tungsten. This tungsten filament. I told you before one, why use tungsten filament? Because tungsten filaments, the characteristic is very easy to admit the light. You can admit a lot light one, tungsten, okay? High resistance. When it become hot now, it can release a lot light. That is a characteristic of tungsten, okay? What energy changes occur? Okay, what energy changes then? Chaiyong, Tan Chaiyong, can you answer what energy change to what energy in the bulb? Tan Chaiyong right? Tan Chaiyong
No.
Yes, please
Electric
answer.
to
What energy
electric to light
changes
energy.
What energy change to what energy?
Electric
Yes.
to light energy.
Electrical energy change to
Electric
light.
energy to light energy.
Half correct only,
Passive.
no? Yes,
Passive
correct.
energy.
Correct. Electrical energy change to light and heat because the light and heat must come together one. Okay. Electrical energy to light and heat. Okay. Yeah. The next one, the power of the lamp, 20 watt. This one 20 watt. Resistance of tungsten is very high, 120 ohm. You see, it is used for 2 hours. So power is 20 watt. Resistance 120 ohm, used for 2 hours. Okay, calculate current flow. Find current. To find current, what formula? E1, right? E1 Find current, what formula You have power, you have resistance, you have the time. How to find current I? E1E1可以出来一下嘛？不用紧E1我看你有回音不用紧。Brian Brian, how to find the current? Use what formula? What formula? Jong Han, Ko Jong Han. With Brian, you answer Ko Jong Han, right? Ko Jong Han What
E
formula
equals IR.
Oh, Brian said.
P equal to IR. Okay can. But it's not IR, P equal to I what? Use a simpler one or use P equal to IV or VI right? Use this one. Put the power inside, put the voltage or no voltage, sorry. So cannot use. No, sorry, So I have to erase You cannot use this one. The funny one cannot erase. Okay, use P equal to I square R. Okay, I square R, this one. Power equal I square R. Find the I okay. Like that, I think can already. Power 20. Resistance 120, so you find the R. So what is the answer? Calculate, please, everyone. This one, don't use this one. Power equal to I square R. Okay, one answer. Jong Han, one answer you get, Jong Han. Ko Jong Han One answer
0.4 0.41 ampere.
0.41, so small. Okay, check the answer. Yes, correct. 0.41. Yes, correct. Jong Han, thank you. 0.41 ampere. Okay. Okay, next one. Electrical energy. The formula already there. Next one to find electrical energy. What formula now? Jeff, can you come up, Jeff?
Yes.
What formula to use to find electrical energy?
I don't know, sir.
Okay, now my line. See start from here. Energy formula is PT. Power multiplied time. PT. Okay. Power, you know already, I square R, so you put here, so it's I square R T. Okay, use this formula, I square RT. Okay. Yeah. Power is I square R, so it become I square RT, So you have the I already, you have the resistance already, you have the time already. I see whether you get the right answer or not. I'm sure some of you sure make mistake one. I keep quiet first, you all do first. So one answer? One, 4, 5, 2, 3, 8.4. Okay, come, let's check your answer. 1, 4, 5, 2, 3, 8. Okay. Yes, correct. 1.45 10 to the power of 5. Correct. This answer given in standard form. So, Jeff, your answer is correct. I square RT. Remember, no, the time must change to second. Cannot use hour. 2 hours mean times 60 minutes times 60 seconds. Okay? Then only you get this answer. Your answer, you can either give it standard form like this, 1.45 10 power 5, or like just now what Jeff give 145 something. In physics, doesn't matter one. Never say must give in standard form. In physics, they never say. Okay. Unless a question stated, you must write your answer in standard form. But this question never mentioned. Yeah. Okay, come, we move on. Now C. I got question. So I cannot straight away use power. Can, Pong. Actually can. PT must straight away use power. Also can, actually. Use a power. But you get the same answer, right? Should be power PT. Power 20 watt. And the time 60. You get the same answer, not Pong? Do you get the same answer?
A bit different also.
Then what is your answer? What you get, Pong? Is it 1.45 or so?
1.44.
Okay lah, like this. I let me explain now. It's actually now you are advised to use a proper formula like you this one. Because any calculations of energy, if you are given current, given resistance, it's better you use a current and resistance. You will get a more accurate answer compared to you use a power direct. Okay, because to get more accurate answer means you have to use more factor. More factor means like using current, using resistance, using time. You involving more factor means your answer will be more accurate Pong, understand or not?
Okay, understand. Thank you,
Okay,
sir.
okay, thank you for the answer. Okay, next. Now you're asked to choose. Table show the comparison between lamp, a compact fluorescent, and LED. Got 3 types of light, This one is normal, decent lamp, normal one. This one is compact fluorescent lamp. This fluorescent means that is daylight. This light is yellow color one. This one is daylight, like daylight one, fluorescent. This one LED light. Okay, LED is like LED light is like the car. Certain car, the new car they have. When you start the engine, you see the car in front there got LED light, isn't it? That one is not nighttime or daytime also with on one, you see the car. That kind is called LED light. Okay. In fact, now most of our house the fluorescent lamp we don't use already now. You replace the fluorescent lamp by using LED because LED light lamp is more energy safe can save money. Okay, you can see now 12 watt only. Okay, LED 12 watt. This one fluorescent, the watt slightly higher, but this lamp definitely no good. You see, so high power. Very high power means it can use out a lot of energy, and then this light come out become yellow color, no good one. Power very high, but the light not bright yellow color. Okay. If you ask me to choose, I never see others. I will say straight away LED is the best Now, in fact, most of the place, the house all we use LED light, LED lamp because you can save energy. Of course, you can save energy, but the brightness is slightly less I know some of you at home also you have LED light, isn't it? You ask your parent, the parent will tell you. LED light you can very fast differentiate one. You on the switch, once you on the switch, you light up very fast one. That is called LED. In normal fluorescent, you on the light, you have to wait 1 second, 2 seconds, then will light up. That is called fluorescent. The one old type one. The LED very fast one. No, you press a button, it already on. Okay, faster one. Okay, come next. Lifespan. This one only lasts for 1,000 hours. This one 8,000. This one you see lasts longer, 25,000 hours. Sure, definitely choose this one. Can save a lot of cost, man. It lasts so long. And producing heat energy, this one a lot. This one less. This one least energy. That's why the best is this one. We know already the answer. Okay. Least energy producer. When produce least energy means less energy loss. Well, actually we want the light, we don't want the heat. Heat is considered a waste already, Okay. Okay, now you know what to choose already, Okay, now you go and answer. Okay, you answer. Power, choose what reason? Okay, answer everyone. Okay, 2-3 minutes go and answer. Finish up everything. Okay, finish, Okay, first one, low power. I want to hear from you. What reason? Why choose low power? The lamp must be low power. Reason is what? Okay, come. Xiao Hui, Ang Xiao Hui. Why choose low power? Reason is what? Ang Xiao Hui. Ang Xiao Hui, no more there already, Tisna, hey, Tisna Tan, come up. Tisna. Tisna Tan. Okay lah, Pong you help lah. Why choose low power, Pong? Pong
Produce
Produce what? Why we
last
choose?
longer.
No. Low power nothing to do with last longer or not one. Donghan, why we choose a low power one?
Save energy,
Yes,
electric
correct.
energy.
Save energy lah. Yes, correct. Save energy and save cost. Okay. Save energy, save cost. That's the reason. Save energy, save cost. Okay, next one. Lifespan, of course, we choose a long one, a long lifespan. The reason is last longer does not require to replace. Okay, life must choose a long lifespan one. It can last longer and does not require to replace oftenly. Save cost also lah, right? Not save money, save cost. Okay, because it can last longer and does not require to replace oftenly. Okay, and producing heat energy. Okay, I want to hear from you all. What you all want to choose? Raymond Ng Raymond, are you there? Raymond
Yes, sir.
Raymond, for producing heat energy, what you choose? Raymond? Least, yeah, you choose least, correct lah. What is the reason?
Less energy loss.
Yes, correct. Very good. Produce less heat. Less, then the reason is reduce the energy loss. Can reduce the energy loss. Yeah. Jeff, what's you said increase the efficiency? Can Chan Chingyi, increase the efficiency can, because reduce energy loss means it's the same meaning as you increase the efficiency lah. Actually same meaning. Okay. Efficiency higher means energy loss is less It's the same lah. Okay. Jeff, I cannot understand what sign you type there. No. Jeff, I don't understand what you put there. Jeff. Okay, never mind. Next. So the best is LED lah. Okay. The last one we choose the LED. This one no argue lah. I just look at the first part already. I know LED is the best already. Okay, come. essay question we try answer a little bit lor, okay, a bit là nèo mai, okay. And get ready with your foolscap paper. It's a time to practice already, no? Where student if you don't practice now, when are you going to practice? Okay, practice. Take out foolscap paper, practice now, okay. Always remember, must be self-discipline, okay. Now you don't go to school, nobody can help you so much, unless you help yourself. So self-discipline very important, okay. Okay, come on. Take out paper. Ready with your foolscap? Okay lah, come, I want to see the evidence. Like the other day, I asked them to show me your paper. Pong Pong Yong Eun, 有在吗？
Yeah, sir.
有纸吗？有 paper or not？
有。
有 ，OK。On camera 给我看一下你的纸可以吗？ On camera 照一下你的纸给我看。
你要看什么纸？
看你的 foolscap paper。
哦，看复习给我啊。
不然呢？
哦，OK。
On camera paper come. Yeah, 看到了。Yes, you have the foolscap paper. Thank you, Pong. Okay, come. What is spring constant? Spring constant is what? How to answer it? First question, you see the essay question. First part, sure they ask definition. Spring constant is what? Definition, no? Jeff,
Yes.
what is spring constant? How you answer?
Spring constant.
Very tough question. I give you a little bit tip so you see here. See, look at the screen. F equal kx. Use this formula to answer spring constant. So spring constant is what? Okay. K is a spring constant now. So when you want to say K, you must force divide by extension X ma. So spring constant is what now, Jeff? Sorry, K. Sorry, this is K.
Force divided by X.
We don't say divided, no. We say force per unit extension. Okay. So you write the answer, everyone, please. I'm sure everyone also don't know one, most of you. So spring constant is force per unit extension of the spring. Force per unit extension. Okay. Force per unit extension of spring. That is called spring constant. Got it or not, everyone? Force per unit extension of the spring. Okay. Now we study a little bit of the spring first. This spring very thick. That's why the spring very strong. You see, you put 200 grams extended a little bit only. This spring be very soft. So very soft because the wire very small, isn't it? Same, you put 200, it extended so much. So this spring is hard, very stiff. This spring is very soft. Okay. So now, question. Brian, what are you? Brian, don't simply type, Brian. Yeah. Again, Brian, sorry, type wrong. Brian, I know you try to be funny, but not funny, Brian. Okay. Okay, come. Compare the thickness of the spring wire, the extension, and the force exerted towards the spring. So 3 marks. There's a lot of marks, Everybody think of it. Come on. Last part, we finish this time, we stop. Compare the thickness of the spring wire, the extension of the spring, and the force exerted toward the spring. So they ask you to compare how to get the 3 marks here. You must write 3 points, to get 3 marks. Okay. You answer one by one, no? First one, thickness. Compare the thickness. This one, you got eyes, so you can see one. Second one, compare the extension. Third one, compare the force. For 3 marks, 1, 2, 3. Okay, come. Let's hear from Brian. Brian, come up, please. Brian.
Yes.
Brian, can you compare the first one, thickness?
The more thick the spring, the lesser the extension.
Why? Compare, Brian, they ask you to compare. They don't ask you the relationship. Compare. Compare the thickness of this, thickness of this. So how you answer, Brian?
Thickness of spring A is thicker than spring B.
Yes, correct. Okay. Spring A thicker than spring B. Okay, that's all. Okay, next one. Extension. Compare the extension. Okay, come. Let's hear from Ku Kian Ming. Ku Kian Ming, 出来.
Yes.
Kian Ming.
Yes.
Can you compare the extension?
The extension in spring A is shorter than B.
Yes, correct. Extensions of spring A lesser than spring B. Okay. And last one, compare the force. Okay, let's call who? Tai Chuan He. Tai Chuan He, can you come out? Tai Chuan He 可以出来吗?
Yes.
Tai Chuan He, can you answer the last one?
Yes.
Compare the force. What answer?
Equal.
Yes, correct. The force equal because 200 gram means the same force. So the answer you say, force exerted toward the spring in diagram 9.1, same as diagram, no. On spring A equal to spring B same okay Okay, so I think for tonight, I stop here okay Okay, now, come back to here again. As I noticed tonight, very quiet, very quiet. I mean, not so good, not a good sign, because I very worried. Some of you not paying attention. Some of you, you can do other things. They want to no good, So, yes, I say quiet, Jeff. Quiet because out of 10 students, I call your name only about 4 to 5 got respond one. Other I call name no answer. No answer, I worried you are not paying attention or you are doing something else. Okay, remember that. Okay. So I always encourage you to have your self-discipline. Self-discipline is very important. Now you must stay strong at home. Depends on yourself very much already, If you have tuition, so you attend a tuition class, you focus. Okay. Your attitude now has become very important already. Your attitude will determine your SPM result because this is the first time in the history from 5 students have the kind of experience one. So now everybody also say the student must have their own self-discipline, very important now. Okay, so remember please stay focused to your tuition teacher during your tuition lesson or during your school lesson. Stay focused and don't forget, continue to study okay, continue to study, stay home and stay safe at home. Okay, so I see you next week. Okay, bye bye everyone.
Thank you, sir.
Yes, bye. Okay, bye everyone.
Thank you, sir.
Thank
Okay,
you,
bye.
sir.
Okay, bye. Bye. Okay, I see you next week. Bye.